time as a software mentor for Netherlands High School's successful after-school robotics program. So this might not actually be Brian, it might be one of his robots. Either way, please join me in welcoming Brian. Thanks.
Okay, you didn't get the robot tonight, you got the real Brian. Thank you, Dave. Topic tonight, space settlement, is a multi-headed topic. And I'm actually going to enjoy this, I think, because I have been giving a lot of science talks lately. We're at the Southwest Research Institute, a lot of things that we study span the whole solar system. Space settlement is a much more focused topic, yet you can take it in many different directions because the whole topic of settlements touches everything that we do here on Earth. Politics, religion, technology, economics, of course. There's several bigger threads there, but it runs the whole gamut. So we're only going to be able to skim the surface tonight and probably won't be able to get very deep into any one of those areas, but I think the format that we wanted to shoot for tonight was to have it be very interactive. So if you have a question as something comes up, just feel free to jump in and ask the question. I think I'm going to talk for about an hour, hour and a half, including the questions and all, but if we need to, we could take a break and refresh our batteries a bit too. So, space settlement. Where do we begin? This is actually a new talk I put together too, based on pieces of 3 other talks I've given before. But as I said, it's been a while since I've talked about space settlement. So some of the science things will kind of creep in there a bit, but the main focus is at a much higher level. So when I was thinking about how I wanted to start today, as Dave mentioned, I've written a novel about Mars exploration, and I have my foot in the waters of the science fiction community and have for several years. So I wanted to start with a little bit of science fiction. And in particular, the topics of space settlement. Whenever you see a science fiction movie, space settlements tend to look something like this. You're looking at very grandiose constructions, whole planetary societies, ecosystems. In fact, I'll ask for your help here in identifying a few of these that I collected from various science fiction movies over the years. And we'll start with that one there, which should be easy, but it's probably very difficult. Anyone have any idea where this one came from? Star Wars, very good. I didn't know that one actually. I had to look it up. And Star Wars is a great example of space settlement because as the characters go around and as the various movies are coming out, you see a whole gamut of settlement maturity, from basic settlements to planet-sized cities. This one was just called The City Planet. We're not going to be talking about that tonight. In fact, that's what I really want to emphasize with this. These are all grand scale endeavors. What we're going to be talking about tonight is very near future settlements. How do you get an initial foothold on another planet or out in space, which could someday lead to something like this, but decades or centuries down the road. So let's just go through them real quick. Anybody know this one? That's an easy one. Babylon 5, there you go. Easy. But it's a great example of what they call an O'Neill cylinder, which is basically a self-contained rotating space station where people live on the inside and gravity pulls you down, but it's out. So a very cool concept, and it's technically feasible, more or less, although very difficult to construct. How about this one? That's my favorite. Anybody? The floating city? Stargate, Atlantis. Yes. This was a city built by a race called the Ancients, very powerful ancient race of aliens, and the city reflects the power that they had. We're not going to be building any City of the Ancients anytime soon. How about down there? This is a recent movie. Avatar, very good. That was a tough one. Kind of an example in a lot of ways of what a settlement should not be, but I won't go into the reasons why. How about up here? Very good. That was the hardest one of all, I thought. That was an 80s movie called Silent Running. These pods are for growing crops. So little aquaculture pods. Not very feasible. That's not a good design for growing crops in space, but we'll get to some of that later. And finally, that's probably an easy one. Total Recall. This was a scene from the Hilton on Mars of the Pyramid Mountain kind of blowing its top. So as I said, though, we need to change our thinking from the Star Wars city planet to my favorite settlement in all of Star Wars. Classic scene there. When I think of Star Wars, this is what I think of. Star Wars is a movie about the journey of Luke Skywalker from obscurity to success, whatever you would call it. And the settlements reflect that. What we're going to talk about tonight is what would it take to build something on this scale? So very basic. And so where do we get our inspiration? Well, past Earth settlements are a good place to start. What does it take for people to live in a new place on Earth that they have not lived before? And these were just examples from US history. Of course, we have the igloos, very harsh climate near the North Pole, but Eskimos are able to live there just fine in buildings constructed from local materials. And that's the key point here. They don't have a lot of resources on the ice sheet, so they use ice. Very smart, very simple, very efficient. This could be, I live up in Netherlands, so I drive by cabins like this every day. 100-year-old cabins that the Solars built out of wood. There's a lot of trees around, again, using local resources. Plymouth Plantation, I believe. Pilgrims, again, wood, some stone. And then, of course, Indian teepees. To get to the teepee, it's not magic. There's no magic to building a teepee. Basically, the formula is tree plus buffalo plus people, of course, equals teepee. And it's the people intelligence that makes it all come together. So, when we think about space settlements, we have to use what is there and our intelligence that we bring along with us or back on Earth. Since we have this thing called communications, our settlers won't be completely on their own. So, what are the important things that you need for a settlement in space? Well, the most important by far is settlers. Duh. You'd be surprised how many times people talk about settlements and they totally forget the people that are going to be living in the settlement. And by that, I don't mean the specific people. I mean the qualities that a person has to have in order to actually give up a life of relative ease here on the Earth, go out in space, and live in an environment that's going to be quite harsh and quite dangerous for a while. Michael Landon has passed away years ago, but if he were alive and if his character were real, of course, he would be a good example of a space settler. You need somebody that can think well on his feet, someone with impeccable integrity, hard work ethic, all the qualities of Little House on the Prairie, for those of you who grew up watching that show. I was not one of them. I've seen a few episodes, but I've seen enough to know that this is the right stuff in astronaut terms. Again, frontier work ethic. Keep that in mind as we go through settlement details. So what else do we need? Well, energy. Energy turns out to be probably, after people, the second biggest requirement. Because if you have energy, you can do other things with it. And I'll get to some of those in a minute. So energy is sort of your currency of a settlement. Wind energy in certain locations might be possible, but that's not a big one. And for the American frontier, wind helped substantially. We're looking for space settlements at more modern, high-tech energy sources. Solar, and in particular, I like the image here because there's a lot of effort going on right now into flexible solar panels. Flexible panels that are easy to lay out and construct your arrays with a minimum of people effort required. That's exactly what you need for a space settlement. Your space settlement is initially going to be very poor on people in terms of their time and numbers of people. So you have to make things easy for them. Laying out a flexible solar array is one thing that could help a lot. Of course, with solar, your power density is very poor. So solar, at best, for a lot of the applications that we're going to be talking about and the places that you might want to build a space settlement, solar works better as a backup power source. You need a primary power source with a lot more oomph to it. And that pretty much, the best thing going for most places is going to be a nuclear reactor. There are companies working on building small, portable nuclear reactors, but even better, there's been a lot of effort lately, within the last 2 or 3 years even, on this technology called self-regulating nuclear reactors. It's basically a reactor that works like a reactor, if all of you are familiar with the basics of how a nuclear reactor works. You know, you have nuclear fuel that builds up a reaction, but with a self-regulating reactor, there's a sort of hard-coded way to dampen the reaction if it becomes out of control. So it can't go critical on you. So there's several companies now that have started marketing these things called, well, the slang term is a nuclear battery. It's basically you put some nuclear fuel into a system, you bury it, and then you get your nuclear power output, mostly thermal, but electrical as well, for anywhere about 10 to 15 years in time before you have to dig it up and replenish the fuel that's in there. Very safe, very portable. These things, the goal for one of the companies here called Hyperion in the Denver area, or it used to be Hyperion, I think they got bought out by somebody recently. But these units are basically hot tub sized. That's their goal. So not too much mass, really. It might be possible to send one of these out into space.
How many kW?
Sorry?
How many kW?
Oh, how many kilowatts is the question? It varies. Yeah, for the hot tub size, I'm trying to remember the specs on that. It's not as much as you're going to get with a small-scale nuclear reactor, which is in the megawatts range. I think you might hit a megawatt with it. I'm really not sure. I'd have to go and check the website again and try to look at some of the specs. This concept has been evolving over several years too, and for a space settlement that is strictly a space settlement, you'll have plenty of power with a couple of these. That I can say. However, you might not have enough for a, for example, let's take a Mars settlement. Most NASA thinking for Mars settlements isn't really to build a settlement. They want to do two-way missions to Mars focused on science. And you would not have enough to create the fuel for your return trip with one of these. It would probably take a couple of them. So, but it's in that range. So very useful. Nuclear batteries is a technology to watch, and it could really enable certain things for space settlement. Geothermal power, if you're looking at Mars, that's a possibility. I don't think it's been ruled out. It might be a good power source someday on Mars, but not for the near future. There's a few other options that I really won't get into, but energy is a big one, of course, that we need. So what can we do with energy? I mentioned that it's kind of a currency. Well, with energy, you can convert minerals and chemicals that you find wherever you are into more useful forms. That's the best use of energy. In particular, water drives everything. So if you don't have water where you are, but you do have a source of hydrogen and a source of oxygen and energy, you can create water. Or the converse, if you have water, you can break the water apart into hydrogen and oxygen, which is a good rocket fuel. Carbohydrates, that's what keeps our people alive. Food. Water, again, critical for food. Water is in everything. So if you don't have water where you're going, you're really in bad shape, because unfortunately the other property of water that's very relevant when you're thinking about space settlement is the fact that water is very heavy. You really don't want to be bringing your water with you from Earth if you can avoid it, because just the mass that you have to bring. Now you will have to bring some, of course, but well, we'll get to that in a bit, maybe. That gets into some details about how you do a mission. So anyway, you can create plastics with energy and these core elements. Very useful. Other resources that are potentially very useful might not be directly useful by the settlers, but they might help you to make an economic case for the settlement, such as gold and other precious metals that exist in abundance in certain places in the asteroid belt. We, of course, don't have first-hand knowledge of that, but it's a pretty solid fact that they are there to be found. Plastic tubing, just an example of, you can do a lot with plastics. A future settlement is going to be very plastic-centered. And other minerals are useful, salt mines, things of that nature. So what else do we need for our basic settlement? Well, you need a way to get there. Rockets are, of course, the way to get anywhere in space. SpaceX, I'm assuming, how many people have heard of SpaceX as a company? I'm assuming most of you have. I'm not going to talk about SpaceX directly in the talk. They'll be referenced indirectly several times. But Elon Musk, the CEO of SpaceX, is basically a Martian. He is doing everything that he's doing with an eye toward Mars settlement someday. In fact, I was just reading an article before I came over here about an interview he gave in England where he's speculating that he wants to lead the way to building an 80,000 person settlement on Mars. And the time frame wasn't listed, but within like the next 50 years or so. That's pretty grand of an ambition there. We're still working on the first 8 people, let alone the first 80,000. So I'm not going to talk about numbers like 80,000 tonight. We're talking about 8 people. But Elon Musk has a vision. He's building his rockets. They're flying. They're real. And he's going to make a ton of money doing it. So when you look at the economics of what's going on right now, he and dozens of other space entrepreneurs are springing up all over the place. And they have realistic business plans, some of them. Some are a little bit out there, or so we think right now, but who are we to say? Another person with grandiose ideas and a business plan to match it is Bob Bigelow. Very wealthy hotel magnate. And he has a company he started called Bigelow Aerospace. They're focusing on inflatable habitats. Inflatables would be excellent for various settlement purposes. He's looking primarily at putting his habitats up in orbit, Earth orbit, sorry. And that is a viable settlement location, but not so great for other reasons that I'll get to in a minute. The nice thing about inflatables is that you can build them very tough, and they're very lightweight, relatively speaking, in order to launch compared to the volume that you get inside them. So for for your human space, for people living room and breathing room, inflatables have a promising future. He just signed a big contract with NASA too. Well, a small contract in terms of money. I think it's $18 million to put an inflatable habitat on the space station. And when I say a habitat, it's really just a very small module. It's sort of like a demonstration project. But he could build one of these that's several times larger than the whole space station itself. He won't be doing that, though. Just want to clarify that. This is just a demonstration thing. So when you hear about that in the news over the next few months, it's a demonstration mission that they're going to be doing. ILC Dover has played around with building some habitat prototypes. Many other companies have done this as well. Some of the work we've done with the Mars Society has been very habitat driven. We're getting a lot of information about what it takes to build a space habitat and live in a space habitat. So, and then my friend down here in the corner, you might recall from my bio, I do a lot of work with robotics. This guy is a robot named Robonaut. He's been developed down in Houston by NASA. He's gone through 3 different iterations now. This is the wheeled version. He can have legs, walk around on legs, but for planetary surfaces, wheels are the way to go. Great thing about Robonauts is they're humanoid. They have humanoid hands, which means that they can be teleoperated by a human with reaction control and feedback that kind of simulates the human actually being there. But even more important is humanoid robots can use humanoid tools. So if you're looking at the tools that you're going to bring along and build your settlement, you have tools that can be used by people. You want the same tools to be usable by robots if you can. Telerobotics is one of the great keys to opening up space settlement. It's one of the game changers. Let's look at economics for a minute. I have a couple of peripheral pictures here because when you talk about space economics, nobody has quite figured it out yet. They think that they have plans. There are definitely business plans out there, but nobody has yet put them all together. I'd say, again, Elon Musk is the closest to actually making money right now. But a lot of the plans fall into 3 categories. One is plans related to space-based solar power, which run into a lot of technical obstacles and might not even be feasible. But there are a lot of people working on this very hard, and if they are able to come up with something, then more power to them. Asteroids, as I mentioned, they are the wealth of the solar system. That's where most of the mineral wealth in the solar system resides. Plus, the other great thing about asteroids is the real wealth in the asteroid belt is probably water. Something basic like that. But as I mentioned, water is very heavy. If you need water for use in space, you want to have a source that's already in space. So, water. And then I have Mars in the corner. Mars, there's a lot of economic potential for Mars and various things, but one of the ones I like the most is just simply the landmass. Real estate on Mars is going to be a booming business someday. Mars has the land area roughly the same as the dry land area on the Earth. So that's a lot of real estate waiting to be developed someday. But in terms of how we get there, there's basically 2 strategies. And when you talk about the economics, there's 2 strategies that people fall into over and over and over and over again. One is sort of the pre-1850 strategy of American expansion across the continent that we live in. If you'll notice, we started out here in the East, the European expansion, I should say. There were Americans Native Americans living all over the place all the time. But the European expansion progressed in a very orderly fashion from east to west, including everything up to the light blue here and actually the light green. So around 1850, you had pretty much the Mississippi River and a little bit beyond in terms of states. And then something happened, something interesting. We started jumping all over the place. New states were formed, and of course states are formed based on population. So the order that states were formed was dictated by where the people were, and you can make some assumptions about why they were there. Well, Texas is kind of contiguous to the rest of the Union, but what happened over here in California and Oregon? Anybody want to take a guess? 1850s, think California?
Oregon Trail was opened up in 1843.
Oregon Trail helped to publicize the fact that you could get there and back, but I think I heard Gold Rush, right? Yeah, Gold Rush. So there was actually an economic reason for people to shuck it all, go west, make their fortune, and the states followed in short order. So the post-1850 module is just a mess because there's really no order to it at all in the destinations that became popular settlements or popular places for settlements. It was very resource driven. So when you apply that to space, which model are we in? The traditional thinking is sort of the 1850s approach where things that are close to Earth are more economically viable. So therefore, we're going to move outward from Earth in a very orderly fashion, and starting with Earth orbit, and then the moon, and then, maybe some Lagrange points, and then out to Mars and all. Well, that might not be the best model. So you have another model that says, why not go to the best place first, where the resources are? And that has to be Mars, which we're going to see in a minute. So Mars is sort of like the California, I think. When I think about the Western expansion, I think of Mars being California. What else do we need? Other possible motivations for settlement. You need a motivation. And some of them in the past have been political and religious freedom, escape from persecution of various sorts. Because we have our pilgrims here. Sci-fi series recently that I just love is called Firefly. So one of the great things about the Firefly universe is that it is very motivation driven. The politics in particular get real interesting. But for settlement purposes, they need a lot of freedom to do whatever they need to do in order to survive and to thrive. What else do we need? Well, again, in the American West, you needed protection from various things. And in particular, settlers sometimes built forts to protect them from the 20-foot tall bears that wanted to sit on their cabins. So there's that. The equivalent to fortresses, if there is one in space, is going to be radiation shielding of some sort. That's sort of the boogeyman that a lot of people like to throw out against space settlement is, oh, there's radiation in space and we're all going to die from radiation. Well, there is radiation in space, and we do need to study it a bit and learn how to deal with it. There's some mitigation strategies. They go from the exotic, like NASA has some plans for local magnetic shields that could shield your settlement from some of the worst types of radiation. But radiation shields can be very mundane things too, just as in this example where you have a future schematic of I believe this was a nuclear engine. If you want to get your settlers from point A to point B using nuclear rockets, you have a big radiation problem on your hand. So you have to shield the habitable parts of your ship from the reactor. And you just do that with mass. And water happens to be a very good way to shield your astronauts. So, so bringing some water with you is a really good thing. Great place if you're on a planet surface. Just build your habitat underground. A couple meters of regolith is all you need for radiation shielding, and it's fairly easy to do. So, other possible motivations for settlements. Tourism. I'm looking forward to when somebody builds the first golf course on Mars. And I want to be there. Of course, with tourism, a lot of the tourism talks center on near-Earth space. And the famous Earthrise picture is used quite often. Tourism to low Earth orbit and to the moon is a viable model. Somebody could make a lot of money doing that someday, and possibly someday soon, as we'll see. But your destinations, they need to have a certain curb appeal, as I call it. You really don't want to build a settlement on a flat plain. That's not going to be very conducive to luring potential future settlers. So you want something good there. And then, as we talked about with resources, there's a wide range of resources if you're looking at a place like Mars. We're mapping those resources out and learning more every day. But one of the resources that might be really important to a future settlement on Mars in terms of location are these things called lava tubes. We see in orbital images where there are huge underground caverns. If any of you are familiar with lava tubes in Oregon, for example, we have them here on Earth, but they're nowhere near the size that you'll see on Mars or on the moon. The lava tubes are bigger than even on Mars. These are underground structures. Sometimes they're not very stable, so you have to pick your lava tube carefully. But they're basically ready-made radiation shelters, just ready to move into. So location, location, location. And speaking of location, so let's back up a little bit and talk about these various destinations that are possible for a settlement. And I'm going to zip through this because I've given a couple of talks at the DaVinci Institute before in years past, and one of them was focused very much on the various possible locations for human activities in space. So I'm going to zip through a little bit, but if you have questions about any of them, slow me down. I don't mean to play too much on one location over another, because each of these locations has advocates of people that really want to go there and set up settlements. And I don't want to kind of poo-poo any of those plans, because if you can build a good business model and you can make it happen, so much the better. So this is our solar system. You'll note right away this big old donut here. And again, as I said earlier, the wealth of the solar system is really in the asteroid belt. So some locations are better than others, but if you're thinking in terms of the wealth of the solar system, you want to be close to the asteroid belt, or in it if possible. So keep that in mind when we talk about Mars later, because it's in a good spot, hint. But let's start closer to Earth. Earth orbit is the place to start. There are plans by various companies. I mentioned Bob Bigelow building his inflatable habitats. That would be great for an orbital space hotel, possibly. Hotels on the Earth are centers of commerce. So building a viable hotel in orbit opens the door to building other structures in orbit that require people to operate them. So it could be the foot in the door for developing low Earth orbit. Of course, there are many challenges with low Earth orbit. In particular, it's a very harsh environment in terms of you're in open space. There's really nothing there. Some people view that as an advantage, but in terms of local resources, that means you have to bring everything with you, basically. And you'll be totally dependent on Earth resources since you are, the closest place to you is the Earth. So, but again, there is strong economic potential. And here's a cutaway on Bigelow's website. I mentioned that he can build these inflatables very large. This one module that they're talking about has more livable space than the whole space station currently. So getting it up into orbit would be another matter. But maybe someday. Moon. That's all very familiar. We see the moon every night. It's very close, relatively speaking, to Earth. So once again, you're dependent mostly on Earth resources, because on the moon you've got a few resources, but they turn out to not be all that useful in terms of keeping people alive, growing crops. In particular, carbon is very scarce on the moon. Hydrogen is pretty scarce too, although there is some hydrogen. But the carbon is a big problem. I'm giving this one a medium for economic potential, mostly because the tourism market could be quite substantial someday. But a very harsh environment, very hard for people to live in the moon. Part of the problem with the moon is that the day-night cycle is about 2 weeks long. That's a problem for growing crops again. It means that you pretty much have to have everything underground and supply all the energy for growing crops from your energy sources, which you need to have, of course. So, how do you do that? I don't think anyone really knows. Asteroid belt, moving farther out now. Although there are near-Earth asteroids, some of which are quite easy to reach. So that would be the next destination in terms of proximity to Earth. But unfortunately, the near-Earth asteroid population is quite depleted. When we do asteroid research, we usually distinguish those populations because the near-Earth asteroid population, if we go back to that previous slide that I had, that's all these dots that cross the blue orbit of Earth here. There aren't many. And the ones that are there are very small and are not representative of the main asteroid belt at all. So what is the main asteroid belt? Again, I mentioned that that's the wealth of the solar system, and people have extrapolated based on known information for over a decade now. And you have various resources, the Earth wealth of which is quite staggering. Of course, if you started mining the asteroid belt and bringing a lot of this back to Earth, then it could be that maybe platinum someday will become as cheap as water. I don't know. There's interesting economics that the people of the future will have to deal with. But the resources are probably there, and people that can figure out how to get to them and use them can probably build a good business model around it. Did you have a question?
Is that per person on Earth?
Per person on Earth, yes. Billions. I think 100 billion, roughly, was the estimate for every person currently alive on Earth. If you take the wealth of the asteroid belt and use today's prices, this was actually back in like 2000, I think the study was done, you'd have about $100 billion per person. So,
what's the cost per person to get?
Yeah, that's the question. What's the cost per person? Unknown. But there are some companies that are quite interested, and they might put some plans together. I'll get to companies in a bit. That's another part of the talk that's coming up. Lagrange points. Have to explain what a Lagrange point is very briefly first. Every planet in the solar system, as it orbits the sun, there are 5 points of relative stability. Actually, there's really only 2 points that are stable and 3 that are semi-stable. We just, for short, we call them L1, L2, L3, L4, L5, Lagrange points. L4 and L5, if you look at Jupiter here, 60 degrees, it's 60. Ahead of Jupiter's orbit and behind Jupiter's orbit, there's a concentration of asteroids there. It's kind of like one of the sinks of the solar system. And Jupiter, being the big planet that it is, has a bigger sink than, say, the Earth or Mars. But for all these planets, they have Lagrange points, 60 degrees in front of the planet and 60 degrees behind the planet. And you put something there and it'll stay there, more or less. So these are potential settlement locations. Unfortunately, there are no resources there because it's mostly empty space, unless you're looking at a Jupiter Lagrange point when there are asteroids there, and those asteroids could be quite useful. So in terms of Earth Lagrange points, which is where people would like to build settlements, I think we might have discovered one Lagrange asteroid at the, I think it's in the L5 for the Earth Sun L5 point. There doesn't seem to be much there. Although, to be fair, we might discover more. It's kind of hard for us to observe the Lagrange points from the Earth. I won't go into the reasons why. That gets into the science talks I give. Very weak economic potential, therefore. But these Lagrange points, if you think back to that O'Neill cylinder in the Babylon 5 picture that I had on the very first slide, they would be, if you could build one of those things at a Lagrange point, that would be a great place for people to live. Because the environment there is pretty mild. You are as far away from the sun as we are here on the Earth, so you could capture a lot of sunlight for energy, maybe use other energy sources. You can build these cylinders huge. They'll stay where you put them. So in sci-fi a lot, you tend to see sort of like enclosed small mini worlds. But we're not going to build that in the next 20 years. You know, maybe 200 years or 500 years from now. So for this talk, they don't even exist. But I mention that because there is an L5 society, and there has been for years, and there are people that really try to keep the idea alive, and it's a good idea someday. That leaves us with Mars, which has vast resources that we're discovering more and more every day. Mineral resources, atmosphere of Mars is a great resource. It's got polar caps, there's water everywhere, almost everywhere. Sorry, almost caught me there. Unfortunately, the place we'd really like to have water the most, which is right along the band of the equator, right at the surface, there's not much there that we know of. But could be there, could be there. I won't get into that. That again gets into a science talk. And water on Mars is a very interesting topic. NASA is putting a lot of effort into mapping out the water on Mars. Vast economic potential, as I've hit on, and relative to all these other locations, the environment for people living on Mars is very mild. It's very habitable. In fact, Mars, Bob likes to say in his talks that Mars is the, how do you phrase it, the second...
Second safest place in the solar system.
Thank you. Second safest place in the solar system for people to live. And it is. There's no comparison with anywhere else. And everywhere else gets the big null sign. You know, we're studying, we're poking every corner of the solar system that we can think of to send spacecraft these days. And there's just nothing else within near Earth space that we can reach with settlers that where we can live. So those are the only choices for the near future. Let's take a look at some companies. There's a lot of energy right now in the private sector. You might notice I haven't mentioned NASA much in the talk. The two previous talks I gave here at DaVinci were very NASA-centered. We were trying to figure out what NASA is doing. Well, NASA's not doing a whole lot with space settlement. And I don't really see that changing, at least not directly. However, behind the scenes, they do enable some technologies that are quite useful. I mentioned the Robonaut before. That's a good example. That's a NASA robotic project that would be hugely beneficial to space settlers someday. So who is doing a lot? Well, I mentioned Bigelow before. There's another company called Galactic Suite, which is out of Spain, and they have a lot of nice view graphs about setting up an orbital hotel someday. I haven't seen too much concrete progress out of them, but these two companies are at least in the running with the idea of building orbital hotels, Earth orbit hotels. someday that's going to be a big thing. It might be someday soon. The technology is developing, and it seems like a feasible business model that they're following. Golden Spike, that's a new company within the last year. In fact, there's a tie to where I work. If anyone knows Alan Stern, he is a person that I work with at the Southwest Research Institute, and I believe he's the president of Golden Spike, or some executive officer of it. They are looking at lunar tourism, so that's a tourism company as well. And I'm putting these in a settlement talk because these are not really settlements, but they could open the doorway to settlements. So I'm not going to say too much about them. Golden Spike, the idea is to use pretty much existing hardware, rocket technology, to send tourists around the moon and then someday to land them on the surface of the moon. They, of course, have many obstacles to overcome, but the technology that they're relying on is fairly mature. So if they can make the economics work, then the technology is probably not the problem. A couple of companies that are focused on asteroids, and these are both new companies as well within the last year or two. Just see a quick show of hands if anyone's heard of these companies, either of them. Okay, so there's been big press releases for them, for each of them. Deep Space Industries was just a couple weeks ago, and it caught a lot of people by surprise. And there aren't many good candidates. And the candidate asteroids that someday could be mined by these companies probably aren't even discovered yet, because they're probably so small that we can't even see them. But there are people doing new surveys to get to smaller and smaller asteroid sizes, and so I wouldn't rule them out, but they're looking at some major obstacles. There is a little bit of magic there right now. But I wish them well, because they want to do things out in space, and that could potentially be one of the ways that we start up an in-space economy, which is only going to benefit space settlement. Then we have several Mars companies. Mars One, if you recall from the intro, this is one of the companies that I'm a technical advisor to. They're a very new startup. They're a Dutch company, and they want to send human settlers to Mars, and the time frame is very ambitious. It's within the next 10 years. So a lot of obstacles there. They need to flesh out their technology plan. The main parts, though, are, for the most part, pretty feasible. Then SpaceX, of course, Elon Musk's company. As I mentioned, Musk has had his eyes on Mars as long as he's been building rockets. That's what got him into this. He has specific plans for Mars settlements. I mentioned his 80,000 person settlement that he's trying to, starting to advocate. But that's sort of the end game for him. He's an example of a person who formed a company that's doing concrete steps, building rockets, where each step of the plan is hopefully profitable. And when he gets ready to make the jump to Mars, whether that be in 10 years or in 20 years, that's the time frames he's talking about. So this is no longer some distant future, pie-in-the-sky science fiction Mars settlement type of thing. Elon Musk is actually going to do something. At least that's the vision. Then a company called Four Frontiers, which is having a lot of funding problems. Of all these companies, I like their business model the best. Four Frontiers, basically, they don't really favor one destination over another, although most of their early research has been Mars focused because they see the potential on Mars. That's where the resources are. So EMMA is their little acronym for Earth, Moon, Mars, Asteroids. That's the 4 frontiers of human habitation. 4 frontiers, the great thing about their business model is they're going to make tons of money someday, and they're going to do it right here on Earth. Because the space part is an extension of things that other companies are doing, so they would applaud anything that SpaceX does and all. But their plans for actually making money are right here on Earth, and it's basically in the tourism industry on Earth. So I won't go too much into that. You can check their website for public details, but I'm an advisor to them too, and I'm privy to a lot of private stuff that I can't really talk about in a talk. So. Let's talk about Mars a little bit. So Mars is a big planet. So saying, oh, we're going to build a settlement on Mars, that's about like saying, oh, well, okay, I feel like forming a new settlement on the Earth. I'm going to form a new settlement on the Earth. Okay, well, where? The things that are important for Mars, one is that you have if you can do it, you want an equatorial location. And the benefits that gives you, pretty much it's the day-night cycle and the season cycles. It's going to be conducive for your day-night temperatures, for your solar energy that you collect, which is important for growing crops. One of the biggest benefits of Mars is that it's very Earth-like. And one of the properties that makes it Earth-like is it has pretty much a 24-hour day-night cycle, just like we have here on Earth. It's a few minutes longer, like 39 minutes longer. That's great for growing crops, as opposed to, for example, the moon. I mentioned the moon, the day-night cycles are 2 weeks long. That's a long nighttime. Things get very, very cold. On Mars, not as much. It's still a problem, but it's not as bad. Energy, of course. Mars does have a problem with energy, I guess, in that it's a little bit farther away from the sun, but solar energy is still a very viable thing on Mars. In fact, on the surface of the planet, if you look at your energy input from a solar energy array, it's roughly the same as what you would get on Earth when you account for other factors like weather and atmosphere scattering and things like that. So solar energy is pretty viable as a backup power source on Mars, we'll say. And if you're in an equatorial location, it would make a good backup. For near future settlements, low altitude is important. And there's a couple reasons for that. I think I'm going to kind of skim over them, though, because that gets more into the science talk, which I don't want to get into too much because I'm running short on time, and I want to get to more important things, more interesting things, I'll say. Water. Water is everything. For settlements, you've got to have water. Unfortunately, water is in a lot of locations on Mars, but the near surface water tends to be at latitudes of 45 degrees and higher. Maybe you can stretch it in some places down to about 40 degrees, right about in here. But the closer you are to the poles, the more accessible water you're going to have. So right away you see there's a problem because I just spent a lot of energy saying, oh, well, you want an equatorial location for your settlement on Mars. But that's not where the water is. Fortunately, there might be a way around that. And the answer is probably that there are equatorial sources of water. We just haven't discovered them yet. It's looking quite likely, though. And the evidence is coming from a wide range of sources. We have a lot of orbital data from Mars, so there's a lot of remote sensing that leads us in this direction. But there's a lot of theory about Mars, too. And in particular, this thing called obliquity, the tilt of the planet. We see Mars as it is today, but 1 million years ago or 2 million years ago, the eccentricity of the planet and the obliquity of the planet, the tilt and the orbital parameters, were a little bit different than they are now. In particular, the obliquity, it wobbled a lot more. And when that happens, There's a threshold that's reached at around 45 degrees of wobble. The current wobble is about 24 degrees, which is about the same that the Earth wobbles, hence the same seasons that the Earth has. When you get to about 40, 45 degrees, all of a sudden, the equatorial regions become the coldest place on the planet. So it is quite likely that there has been water near the equator in the past, and some of that water could have been buried up and is still waiting there today. We just have to find it. So we can't give up on that. Unfortunately, if you're going to build a settlement, you don't want to have the most important resources be things that you wish you could find and you think you're going to find, but you don't really know. You've got to have some proof. So people are working on that. Other resources: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, the basic elements of life. Mars does very well with all of those.
How come it's a little poor on nitrogen? Is that true?
The atmosphere of Mars is, I forget the percentage, it's less than 5% nitrogen. I think it's more like, 2.7. And so that's a lot less than what we have on the Earth, but that's very usable. So you basically get it from the atmosphere, which is easy with atmospheric pumps. Take your air in, separate the nitrogen, and you've got it. So, safety, of course. Remember the 20-foot bears sitting on settlements. For Mars, there are hazards. There are things you're going to want to keep in mind when you build your settlement, so you can keep your people safe. None of them look like showstoppers, especially if you can find some lava tubes nearby. That would be awesome. The scenery on Mars someday is going to be just spectacular. Mars is a vertically rich world, I like to say. You can kind of see the altitudes here on the scale bar. There's basically 20 kilometers difference from the lowest points to the highest points. Way more than we have here on Earth. The mountain ranges are going to be just beautiful. Economic potential, growth, we talked about some of that. Oh, but the main one, of course, is just its location. It's near the asteroid belt. So again, keeping with the theme that someday the asteroids are where the wealth of the solar system will be mined, Mars is going to be the place that all that wealth flows through. Mars 1. I mentioned that they want to build a settlement within about 10 years down the road. They've been doing some settlement research, site selection research, to try to find the best places on Mars for the type of mission that they're trying to put together. And they have a lot of things that they're looking at. I'm trying to help them out with some of that. For right now, I think the site that is in the lead is this dotted area. There's a crater in the northern plains called Me. It's very close to where Viking 2 mission landed back in the 70s. Viking 2 is just a little bit southwest of Me. It's very low in altitude. The bluer than blue areas here, very low altitude. It also looks like it's an area that is very rich in subsurface ice, very shallow subsurface ice. In fact, it might even be too shallow. So here's a place where you have water and you have a mid-latitude region which maybe could work in terms of your need for an equatorial location. It'd be nice to stretch this farther down if we can. So I would like it if we got more information about some of these areas that were closer to the equator. Backup sites. Gale Crater is where Curiosity rover is exploring right now, and I could have included Terra Meridiani, where previously the Opportunity rover is roving since 2003. The reason those are good backup sites is just that we know a lot about them now. Actually, Gale, we don't know too much about it yet, but we're going to soon. So, backup site, if we find that the resources are there, then it'll make a good site because we know a lot about it. Medusa Fossae, that's the site I chose for my novel. And I put a lot of effort into researching various places on Mars. Medusa Fossae, on the next slide actually, it's right over in here. Olympus Mons is right there. That's kind of a point on Mars that everyone likes to kind of use to get their bearings. So it's kind of southwest of Olympus Mons. There's an equatorial region, and we're right on the equator there, called Medusa Fossae. It's a weird place. I think I'll just leave it at that. But there are theories that suggest that you might have sources of water there. So that's what's important. So the conclusion of the first part of the talk, before I get into detailed settlement strategies for Mars, which is the second part of the talk, those are your factors. If you're building a settlement, these are the things that you're going to be the most interested in. So I'll leave it at that. And so it's about 10 after 8. I don't know if we want to take a short break, let people kind of get a little coffee. Think that's a plan? Okay. Yeah, let's take a 5-10 minute break. Okay, I'm told to just start talking, and that's one thing I can do somewhat well. People say I talk too much, especially when Mars is involved. So I'm going to start up with the second part of the talk. I'm going to keep this short, and hopefully we can lead into more of a two-way discussion. In particular, there's probably a lot of interest in the economics of Mars. And in fact, I was just talking about that. It's very hard to build a short-term business model for Mars, but some of these other destinations and some of these companies that I mentioned, they have their ideas. Elon Musk, for example, has his ideas, and there are some things to be said there. So, first I want to mention a book of short stories that I helped to bring about. I was one of the people that recruited a lot of science fiction authors. And we have some big names in children's writers, in particular, Jim Denny, Marianne Dyson, Ben Bova, contributed to a collection of short stories about settlers on Mars. So if you go out to your Kindle site and search for Callahan and Mars, you'll find the book, and I would highly recommend it, especially for you since you're a middle school teacher. It's aimed at middle school kids, and I think they'll enjoy it. So, Callahan, Mars. Got it. Great. Second part of the talk, a lot of it comes out of a study that happened for Mars settlements back in 2006, 2007. A group got together in Atlanta of about 30 engineers and scientists, and they dived into every facet of a Mars settlement. And I'm only going to skim the surface here too, because I'm told that I need to shoot for like 15 or 20 minutes, but you could talk for hours on this stuff. For Frontiers, as I mentioned, their plan is to make money on Earth, but they want to apply that money toward Mars research and Mars settlement to make the whole settlement proposal profitable and reasonable for others. So here we are, motley crew in Atlanta, sweltering in the November heat. I grabbed slides from a different presentation, so I have a few extraneous ones. This at the time in 2006, it was a little bit more rare than it is today to have a quite wealthy individual who has his eye on Mars. But this is T. Boone Pickens. And in his office, when he comes into work every day, he goes to Mars. There it is. Some other people, Elon Musk, Burt Rutan, Stephen Hawking, This is Mark Homnick, he's the CEO of 4Frontiers. This was a little montage of the settlement study group. Just love that image, it's kind of cool. They came up with some graphics of what a settlement might look like someday, and that's really what I want to kind of focus on in this part of the talk is, let's visualize what a settlement would really be. Large parts of the settlement are underground. Other parts poke out from a hillside. Again, the underground part is necessary due to concerns about radiation, but also the day-night cycle on Mars, temperature-wise, is such that your underground parts of the base are going to be a little warmer. That's a good thing. I'll get to a schematic in a bit. I'm not going to go too much.
Gravity make it more difficult to grow crops?
For growing crop, the question is, will the change in gravity make it more difficult to grow crops? There's research being done on that, but it's kind of difficult because we just have one gravity for the most part here on Earth. I think the leading theories are that the gravity is not a very big concern. Crops tend to adjust, and you can even grow crops in microgravity. They've done a lot of research on the space station with growing things. But there are problems in microgravity. Mars gravity is about 1/3 of what the Earth's gravity is. Probably for growing crops, the assumption is it's okay. The other thing that the 1/3 Mars gravity does help you with, that's relevant to this slide, so I'll just mention it, is anytime you're moving Earth around, it's a lot easier to do it on Mars. It doesn't weigh as much, although it still has the same inertia, so. So anyway, if you think about burying a base on Mars as a huge, difficult thing, on Mars it's easier than it would be on the Earth. The 4Frontiers settlement study talked about a lot of areas. These were some of the main ones, but they went into more areas. I'll very quickly touch on all these, starting with, whoops, oh, went the wrong way, sorry, bootstrapping. This is very relevant to our discussion. So we're talking about, in the talk here, how do you start an initial settlement on Mars? That's the bootstrapping problem. You have to start with your first people. How many people is that? Well, for 4Frontiers, this was actually their Gen 2 study. So they were looking at the second step. The very first step, you would start with perhaps 2 or 3 different crews at 2 or 3 different launch windows, which are every 2 years. So over the span of about 6 to 8 years, you might send 6 people, and then 6 more, and then 9 more, or you could do 993, or you could do other combinations. When do you send your people? And how many people you send is actually a complicated question, because the first set of people that you send there are going to have the hardest time of it because there's no local infrastructure in place until they create it. So you really want to minimize the number of people you send up front, but you want to have enough so that they can do what they need to do. So what is that? It's a big set of trade-offs related to crew skills. It also depends on where you're going, your whole settlement plan.
Not be sending robots before that?
Yes, question is, will you not be sending robots before that? There's a lot of mission plans out there. Most of them do rely on some sort of pre-staging through robotics and earlier supply missions. And if I have time, I'll get to the Mars One plan, because they've pretty much formed their whole plan around the pre-staging efforts. So yes, you won't be landing your people there most likely with just what they brought with them. They might have a little bit more. So what you really need are resources to build this. Oops. And water is the most important. 3 sources of water. One is just surface ice. You can see in a telescope, you can see the ice caps on Mars. So we know there's ice there. We know there's plenty of water. It's just finding it. Aquifers, it's quite likely that there are underground aquifers on Mars. Not entirely proven, but like 95% proven. And then a lot of the minerals that we see on the surface, many of them are very rich in water content, hydrated minerals. Other things you need, iron, sulfates. Mars stinks was a term for a while because they're everywhere. Silica is a little bit rarer, but it's probably fine. Aluminum, et cetera, et cetera. Won't go into that. Skip. Construction techniques. The Four Frontiers study looked at how you build things on Mars. And one of the biggest problems that they had, they like concrete as a building source, but on Earth, a lot of times when we build concrete structures, we reinforce them with rebar. It turns out that the metal rebar is really hard to build, to create. It takes huge machines to roll out rebar on the Earth. So that's a problem. There are some ways around it, but turns out that was one of the significant issues that they came up with. Yes, question?
What about basalt?
Basalt is quite common on Mars.
Basalt fibers?
Yeah. Oh, basalt fibers.
Replace regional?
I don't recall if they looked at that as a possibility, but if it's possible to use basalt as a substitute. Their biggest problem was with the toughening process. I'm spacing on the right word. The tempering, thank you, the tempering process. That's what needed all the equipment. So if there are other materials to get around that, then that would be a good thing. Okay, here's the schematic that I mentioned. The important thing to take in from all this, other than some of the key pieces of a settlement, your greenhouses in particular, and this area which is buried into the hillside, everything down here is buried. So you have your living structures buried, you have some greenery underground, protected, dining areas, common areas, kitchen, some administrative areas, your control center, and then some exposed manufacturing areas, some garages to work on equipment so you can get to the outside. Okay, that's all fine and dandy. You won't see the nuclear reactors on here. They were big advocates of nuclear power, but you put your reactor a little farther away from the settlement, so for obvious reasons. That's why it's not on here.
Is radiation a problem with the greenhouses?
Question is radiation a problem with the greenhouses? It can be, because your day-to-day radiation you can probably shield against even in a transparent greenhouse, but if a solar flare hits you, everything in an exposed greenhouse is going to probably die.
No.
But there's ways around it. These are your greenhouses, and they look a little different. These are already buried with regolith. And as we'll see in a minute, there's more than just crops in there. So you don't have to have completely exposed greenhouses. What you really want is you want to channel your sunlight into the greenhouse somehow. So if radiation turns out to be a concern, there are ways to deal with it. That's the take-home point. But the other take-home point that I wanted to emphasize in looking at the schematic, and we can see it from here too, take a guess how many people a settlement like this could be built to support. What's the optimum number of people in a settlement of this size and complexity? If anyone wants to hazard a guess. A few hundred. Thousand.
A dozen.
Dozen. Steve, you've heard this talk before, haven't you? That is actually, in initial startup mode, a settlement that would house about a dozen people. So that's a problem. However, it can be expanded quite easily to house more people. So your initial startup cost here is a little daunting, but the expansion possibilities are not as daunting. So something to keep in mind, you need a lot of stuff before you can make more stuff. Notice the tree underground There are ways to channel sunlight into your underground structures used on Earth for centuries. Transportation, let's skip that. Power generation, there's portable nuclear reactors. I think well, no, it's a future slide. So we'll skip that for now. Okay, bootstrapping again. Bootstrapping 101, when you look at your people and the skills that they need. In the Four Frontiers study, they looked at the initial crew of 9 people that you'd want to send to Mars, and these are the skills you need. And I might not be the best at math, but I think that adds up to more than 9. Now, this is where, well, there's a couple of ways around this. One of them is the question before was about telerobotics and AI. So with technology, you can eliminate the need for some people. Also with cross-training, you can minimize this problem. If you have one human crew member, they could have 2 or 3 different skill areas. So it's not as glum as it looks. Four Frontiers was very nuclear power centered, and hence the scary part about the nuclear engineers being needed. I think they were overestimating there. But suffice it to say that the mix of skills on an initial crew is a problem. Cargo delivery, let's skip that. Basically, take-home point here is that about 10 to 20% of the mass that you launch from Earth is actually usable payload for Mars, or like 10%, I think. Does that sound about right? Or,
From Earth or
from Earth.
lower orbit?
From Earth. I think this is from Earth. What's the blue bar here? I'm having trouble with the. I think it was from the surface of
About 20% of your
Earth.
mass in low Earth orbit, you could get onto the surface of Mars.
Okay, then this is probably low Earth orbit. That's why there's no launch fuel. TMI is your fuel to get your trans-Mars injection phase. So okay, I'm sorry, thank you. This is low Earth orbit to Mars. So about 20%,
Yeah.
sounds about right. Okay, and their take-home point with getting to Mars is hard. But, you know, if this was easy, we would have probably done it already. Much harder getting back from Mars is the observation. Yes, there's no doubt about that. In fact, in the Mars 1 plans, it's basically the initial missions are one-way missions. They want to throw that return problem back to the future, push it back. Someday, hopefully we can do a Mars return. They just don't want to do it right away. They want to break the problem in half and solve the easy part first and do the harder part later. Entry, descent, and landing, some issues there. With the Four Frontiers plan, which again was very nuclear focused, their smallest nuclear reactor that they thought was viable has a mass of about 11 tons. And this already has a lot of assembly required. So the smallest unit of mass that you can't disassemble anymore is 11 tons. So you have to have a landing system that supports at least 11 tons of mass. NASA is looking at much more capable landing systems. There are lots of plans on the drawing board for anywhere up to payloads of 50 metric tons, 100 metric tons. You know, it just gets harder and harder as you go up. But the Hyperion nuclear battery sort of technologies, as I mentioned earlier, I don't know how massive those are, but I suspect they're a lot less massive, and there would be a lot fewer. So they did a lot of that with their study. And then I mentioned the open greenhouses. You want to maximize your solar energy input there. Maybe there's a problem with solar flares, but you might need some extra shielding. That's fish again, talked about that. Spacesuits, interesting topic. You're going to need spacesuits on Mars. The old Apollo style of spacesuit, You could maybe get by with it, but they're bulky, they're hard to work in. It'd be nicer to have a better spacesuit, and there are people working on it. This is a prototype of a skin suit. It's being developed at MIT. I don't know if it's a prototype anymore. This slide is years old. Dava Newman is a researcher here. I don't know the latest with skin suits, but a lot more flexible. And then communications was another area that they hit on. Your settlement has huge communication needs. All these scattered bits of equipment need to be worked into a cohesive unit because you don't want this to happen. It's one of our Mars Society volunteers. I think that's MDRS, I assume. Yeah. Okay, and so then I had Mason Callahan in here again because Four Frontiers sponsored the collection of short stories that we put together. So we graciously thank them. And then I had a few slides about the Mars One plans. And I should probably go through very quickly. Mars One, again, this is the group from the Netherlands that wants to send people to Mars in 10 years time frame. So by 2023, that's when you'd send your first people. That sounds really ambitious. And it's like, wow, there's no way. Their funding levels are fairly modest, but I've seen actually cheaper missions proposed. But when you look at their timeline, a lot of it is being pushed back to later years, a lot of the hard stuff. So 2014 to 2016, in a 2016 launch window, they would basically send a lander that has some cargo in it. That is ambitious right there. But maybe it's possible. Especially, well, another thing I should say right off about Mars One, they're not planning on doing much development themselves of hardware. They want to work with existing companies that already are building hardware. So the logical choice here is SpaceX. And SpaceX is planning landers in roughly that time frame, but 2016 is pushing it a little bit. 2018, you would send a basic rover, and it's just going to look around a little bit and locate a best site for your settlement within the region of that first lander. 2021 is when things actually start happening in earnest. So that's about 8 years from now. You send 6 landers, 4 of them have habitation modules of some sort or other. There's 2 varieties. You send another rover and more supplies. 2022, you start to put things together remotely. Start to do some greenhouse work with inflatables. And at that point, you make a decision. Is there any way that we're going to be ready for people a year from now? And you make a go or no-go decision. Hopefully it's go, and in 2023, you get your first landing. Key point here is that with your crew, as in the Mars Direct proposal, which a lot of this is based on, you send a lot more with your crew than you might actually need, given that you have things there. But you want to take into account the fact that your crew might not land very close to the settlement that you're putting together. Maybe something goes wrong. So you want to not leave your crew stranded on Mars with no supplies at all. So it's a fallback position. So you send a lot more supplies with them. And then 2025, you send more. Same type of strategy though, because you have your cargo units and another rover so they can get around. And then 2030, who knows? The Mars One proposal could morph into an early Four Frontiers sort of a settlement. Okay, question is what happens to human health given the gravity of Mars, which is more or less 1/3 of Earth's gravity? Answer that I would give is we don't know exactly. We can make some good guesses. There probably won't be any serious health problems for people. This is extrapolation from tons of studies at 1 gravity on Earth, and then quite a base of studies on the space station at microgravity. Problem is, how do you extrapolate in between? It's hard to do studies like that. There have been a few attempts. If there's an area of concern, it might be with childbirth. I think that's the area that some people are a little bit uneasy about, because that's a difficult process. And it could be, if there are gravity issues, that maybe that's where you start to see them. But I think day-to-day health issues, I don't think there's too big of concerns there. Yeah, Jim. Okay, question is, for the first people there, who are you going to send in your crew in terms of their age range and life expectancy? There's a lot of studies about that. A lot of them have taken place in Russia. Crew studies, demographic studies, age-related studies. One of the findings that, well, basically, to answer your question, it's a bit of an open issue, and there's people that have different opinions. But one of the things that came out of a lot of Russian studies is they tend to favor older astronauts. Part of the reason is this life expectancy thing. It's sort of a worst case thing. Well, if you send older astronauts, they're not going to live as long anyway. That's the negative approach to take of it. The positive approach is, the positive spin, I should say, is they believe that older astronauts are more resistant to radiation. So if you believe that radiation is a concern, and then to some extent it is going to be a concern, then you probably want to send older astronauts for that reason as well. Plus, a third reason is your older astronauts are probably going to be past childbearing age, at least for female astronauts. So you sort of use age as a way to eliminate that concern right away, perhaps. That's another thing you can deal with later. First element. Great question. We're dealing with economics and legal matters. Law is another one of these huge topics that you can form a whole talk about. If Elon Musk goes to Mars, will he own Mars? Probably not. There's probably some middle ground there. Will he have property rights on Mars? That's a tough question. I think you get different answers from different people in the legal community. One would hope that he does, but then what basis do you base that on? Who has legal jurisdiction in space? It's a bit of an open question right now. There are people in the legal community working it, though. A lot of people like to refer to existing Earth treaties, and the one you hear a lot is the Law of the Seas, which establishes certain legal rights in the oceans of the Earth. It's not entirely relevant for farther out in space. So maybe some things in that will be used as a kind of a foundation for property rights. Maybe not, maybe it'll be something totally different. But the key point here is property rights. That's critical. A lot more could happen in space if the legal framework was there to support it. And right now, there's a ways to go. So, great question.
All right, well, thank you so much, Brian. It's been very interesting.
All right.
And thanks, everyone.
Thank you all.